Hello and welcome to CSC Core Concepts in the series of UML diagrams. In this video, I am going to discuss about how to draw a state diagram. State diagrams are also popularly called as the state chart diagrams, and they come under the category of a behavioral diagram, that is, they represent the behavior of the system. Now, basically, this system behavior of the system change is dynamic in nature. Let's say when I am performing a login, then my system is in which state? In a user authentication state. Now, when I change it, okay, when I am doing a successful login, where will I go? I will move to a separate state, that is welcome screen, or maybe I am placing a order, right? So the state of the system changes, and at a point of time, what is the system state and what event is triggering it to change? Because when you say username, password and submit button, this event makes it change to the next state. So this is what is shown in the state diagram. So for example, if you are performing a user verification process, you swipe a card and the system is waiting for your PIN. So it is in which state? It is in a waiting state. Then when you enter the PIN, it goes to a verification state. So this way either gets rejected or it gets authenticated, and so on. The state keeps on changing to some external stimuli. Stimuli means events. So let us see some of the notations of the diagram. So we first start with the initial state. So a black filled circle is showing the initial state. Do remember one thing, that you do not need to write the word initial state. The figure itself is explaining that it is the initial state. Then comes a transition, that is when you are moving from one state to another. So for that you represent it using a solid arrow. So this arrow is used as a transition, and on the arrow you are going to write the event that because of which the state has changed from one to another. The state is represented using a rounded rectangle, that is, you can see the curves here, they are rounded, they are not sharp curves, and you have to write the state inside this rectangle. Then comes a notation called fork. Now what is a fork? You can see a solid bar here, and these are the two states, right? So a solid rounded rectangle, this rectangle is little bit thick in nature, and it comes with one incoming arrow and multiple states. So this shows that one parent state is creating multiple new states, and these states are concurrent. See, don't misunderstand it with a decision. Okay, so it is like it is a concurrent state, that is B, because of state A, the two states B and C will move concurrently, that is parallelly. Then comes the join operation. So join operation is a rounded solid rectangle. Again the same notation. It is little different from fork, where you have only one incoming arrow and two outgoing arrows. But join means these two states are joined together. These were done parallelly. These two states combine to create a new state. Understood? So that is shown using a join operation, that is, they converge into the occurrence of one occurrence of event or events. Then comes an interesting state which is called as a self transition. Means you have an arrow, you can see an arrow which is pointing to itself. What that means is there might be scenarios when the state does not change when any event occurs. Okay, that is called as a self state. What does it mean? Let's say when I am typing. Okay, so when I have written one character, the state is not changing. The notepad is as it is because it is waiting for the next text. Only when I press save and if I close, then only the state changes to a closed state. Okay, so here you can see that you are inserting one character, one character you are inserting for the text. Understood? You are loading a file, you are waiting for a command. Command means, let's say you have said new file, and you start inserting the text. So when you are inserting the text one after the other, you are inserting, so it is not changing any state unless you are pressing save and quit. So when you press save and quit, then only your state changes to an empty or closed state. So these type of transitions are called as the self transitions. Then comes your composite state. Composite state means when you are using the rounded rectangle and you can see a line here because you are representing the internal activities in this composite state. Let's say for example, this installation. So this installation is one state. Now in installation state, what you are doing, some activities you are doing. So on entry, ask installing questions, how many drives you want to split, do action, install the software, and many such. Let's say if you have a disk error, okay, some problem has occurred and you reached a disk error state. So there, what you will ask, an alternative, fix the question, show the dialog question, whatever, right? So you are serving a customer. So customer authentication is one state, transaction is one state, understood? So you are applying multiple states inside, multiple activities inside one state. Then finally you have the final state where there are two circles. The inner circle is a filled circle and you have an outer circle. So whenever you are told to draw a state diagram, the steps you have to follow is that first, when you identify the system, you identify what is the initial state and what is the final state. Then you identify what are the intermediate possible states, and then you, using the proper diagram and the notations, you transit from one state to another, and you have to identify the events which causes the state to change from one to another. So let us I will show you one example. This is showing the initial state. You don't need to write it. This is the transition. So when you start, you give an invoice. So when you give an invoice to somebody, that time the system is in an unpaid state. Okay. Now after he pays, it goes to a paid state, right? So these are your states. This is the transition. This is the event. This is the initial state, and this is the final state. So let us see one more example. So when you switch on the toaster, suppose you want to make your breakfast. So you turn on the toaster, you are in the on state. When you start, yes, working, you put your objects inside, you start working, it goes to your which state? Working state. And when sometimes we have these electrical appliances that after certain time the timer will go off and again restart. So if it reaches the upper limit of the temperature, it will go to the idle state. Now this idle state, you can either turn off the heater, okay, and when it reaches again the lower temperature, it will automatically start working, right? Like ACs, you have a cutoff, right? Then when you press the shutdown button, it will go to the final state. So when it is in the idle state, that time also if you want to press the shutdown button, it will go to the shutdown state. So let us see a state diagram for an ATM. So initially you are starting, the machine is off. So first of all, you are going to give a test, right? What self-test? Self-test means what? See, you can see here that your arrow is going here, right? So you go for a self-test. So self-test may, let's say you start, turn on or you start up. Maybe some button or you can give your card, whatever, right? Start. Now you can go, it can go to an idle state, maybe nothing is working, that's fine. Self test is, suppose the ATM machine was switched off and you switched on that machine. Okay, start up. So the machine takes time, like your system, it takes time to start up, right? Then it will go to an idle state, right? Or it will go to a failure state, means the machine is not starting up, so it will go to a out of service state. Otherwise, it is in an idle state until some customer comes. Now, when the customer comes, he will insert the card. So, when he inserts the card, you come to the state called servicing customer. Now, this servicing customer has a sub-state. You can see here. So, in this way, you can even show a sub-state. So, you go for the customer authentication state. Then you select the transaction. He performs the transaction. See, these states you can even write more detail, like insert the PIN number, authentication state, enter your amount, transaction state, like that. Okay. Now, when he presses cancel, the system again goes to the idle state. Now let's say, for example, it was in an idle state and you want to perform maintenance of the machine. So if you are pressing service, then it goes to a maintenance state. Okay, from maintenance state again it can go to a self test that it is working or not. In the maintenance test, if the system has failure, some major problems, it will go out of service. Otherwise, it will out of service. Say when you perform some service, it will go to the maintenance state. Okay, out of service, machine is not working, you perform some maintenance. And while servicing the customer, if some failure occurs, it will go to out of service state. And when you press the turn off or shut down, it will go to the turn off state. Understood? So this is how your system, the different states are changing, and these are the events which are triggering the changes. I hope you understood how to draw a state diagram. You can practice with more examples of your choice, and do like, share and subscribe to CSC Core Concepts for more such informative videos. Thank you.